Welcome to the DIY Honda Garage channel. The DTC P2229 indicates an issue with the BARO, Barometric Pressure sensor circuit, specifically pertaining to high voltage readings. The BARO sensor plays a crucial role in providing altitude-related data to the engine control module, ECM, allowing the vehicle to adjust air-fuel mixtures for optimal engine performance. This sensor is typically located within the engine compartment, often mounted to the intake manifold or as part of the ECM. When the reading exceeds normal voltages, it can indicate a malfunction either within the sensor itself or the associated wiring and connectors. It is essential to begin troubleshooting with a thorough understanding of how atmospheric pressure affects engine performance and how the BARO sensor interacts with other engine management systems. Proper diagnosis will not only confirm the DTC, but also ensure accurate repair and maintenance actions are taken. The Barometric Pressure (BARO) sensor measures the atmospheric pressure surrounding the vehicle. Its primary function is to inform the engine control module, ECM, about current altitude conditions, allowing the ECM to calibrate fuel injection and ignition timing accordingly. This sensor's accurate operation is vital for maintaining engine efficiency and emission standards. In terms of location, the BARO sensor is typically found within the engine compartment, often integrated into the intake manifold or as a separate entity near the ECM. It communicates feedback through voltage signals, typically ranging around 4.49 volts. High voltage readings, as indicated by DTC P2229, suggest that the electrical circuit associated with the sensor is experiencing issues that could stem from wiring faults, short circuits, or sensor failure itself. Hence, understanding its placement and connections is crucial in diagnosing this error effectively. Several potential causes may lead to the P2229 DTC being triggered. Firstly, a malfunction within the BARO sensor is a common culprit, where the sensor may be unable to provide accurate readings due to internal failures. Next, wiring issues such as frayed or corroded connections can disrupt the signal and lead to erroneous voltage readings. Additionally, an outdated ECM software version can hinder the module's ability to interpret data accurately, potentially resulting in miscommunication between the BARO sensor and the ECM. Each of these causes should be methodically checked during the troubleshooting process. Understanding these causes lays the groundwork for effective resolution and helps technicians pinpoint what exactly is affecting the BARO sensor performance. This approach ensures that repairs are appropriately targeted, improving vehicle reliability. When the P2229 DTC is detected, several noticeable symptoms may manifest. The most immediate is the illumination of the check engine light on the dashboard, signaling the need for a diagnostic evaluation. Additionally, drivers may experience performance issues due to incorrect air-fuel mixture adjustments caused by faulty BARO sensor readings. This mismanagement can lead to sluggish acceleration or abnormal engine behavior under varying load conditions. Another indication may be poor fuel economy, as inefficient combustion processes will require increased fuel consumption. Understanding these symptoms is essential for recognizing the impact of the DTC and the urgency for thorough diagnostics and repairs. These indicators serve as early warning signs that maintenance interventions are necessary to restore optimized engine performance. The first step in troubleshooting DTC P2229 involves turning the ignition switch to the on position, which is crucial for initiating the vehicle's electrical systems without starting the engine. This prepares the vehicle for a detailed diagnostic assessment. Following this, the Honda Diagnostic System, HDS, is employed to pull live data from the BARO sensor. The HDS will provide crucial information such as the sensor's current voltage reading and atmospheric pressure measurements. This step is pivotal, as it sets the baseline for subsequent checks. Properly utilizing the HDS will confirm whether the BARO sensor is functioning within normal parameters, which is vital for effective troubleshooting. Thorough preparation at this stage can save time and lead to a quicker diagnosis, minimizing unnecessary repairs. In the second step, checking the BARO sensor data is critical. The HDS will reveal live data, allowing the technician to observe if the pressure reading is approximately 160 kilopascal or 4.49 volts or more. If the data fits within this expected range, it indicates that the BARO sensor is functioning correctly at this moment. Conversely, if the readings are abnormally high, it indicates a possible intermittent failure, contributing to the rise in voltage. This step is significant as it determines the next course of action, whether further investigation into wiring and connections is necessary, or if the system is currently operating as intended. An understanding of normal pressure values helps clarify the significance of results obtained from the HDS during the assessment. The third step in the troubleshooting process involves ensuring that the engine control module, ECM, is equipped with the latest software version. Simply put, outdated software can lead to miscommunication between the ECM and the BARO sensor, contributing to the high voltage readings triggering the DTC. If the ECM is found to be outdated, updating it to the latest version will improve its function, ensuring effective interpretation of sensor data. Furthermore, if updating does not resolve the issue, substituting the original ECM with a known good unit is advised. This substitution helps to ascertain that the problem lies within the ECM itself if the issue persists. Properly addressing ECM software status is vital as it affects the vehicle's overall engine, management, and performance. In the final troubleshooting step, checking for pending or confirmed DTCs via the HDS is necessary. If DTC P2229 remains present, then the next course of action is to examine the connections and terminals at the ECM for signs of poor connection or loose terminals. These could contribute to increased voltage readings that triggered the DTC initially. If the ECM was recently updated, but the DTC persists, substituting in a known good ECM is recommended to further pinpoint the issue. If no further DTCs are indicated, the troubleshooting process can conclude if the ECM passed checks and the issue resolved. However, if other issues arise during this step, the technician must follow the specific DTCs related to those new indicators to ensure a comprehensive diagnostic approach. After conducting the necessary repairs related to DTC P2229, verifying the repair's success is an essential final step. This involves confirming that the DTC is entirely cleared from the vehicle's memory using the HDS. Following this, a thorough performance check of the BARO sensor must be conducted to ensure it is functioning correctly and providing accurate readings. This can typically be checked by monitoring the voltage output under varying atmospheric conditions. Finally, a test drive of the vehicle is advised to ensure that the vehicle operates smoothly in real-world conditions without any emerging issues. This comprehensive verification process ensures that the repairs made fully address the root causes of the initially suspected DTC, helping maintain vehicle performance and reliability. To prevent issues such as DTC P2229 from recurring, establishing a routine preventive maintenance program is vital. This includes staying up to date with regular software updates for the engine control module, ECM. Keeping the ECM software current enhances communication with the BARO sensor and minimizes potential misinterpretations of sensor data. Additionally, performing periodic system checks can help identify early signs of sensor or connection issues before they escalate. Regular inspections of wiring and connectors leading to the BARO sensor further help in identifying any physical damage or corrosion that may affect performance. Engaging in proactive maintenance not only saves time and costs in the long run, but also ensures the optimal functioning of the vehicle's engine management system. In summary, DTC P2229 indicates a high voltage reading from the BARO sensor, signaling potential issues with the sensor or its circuitry. Understanding the function of the BARO sensor within the vehicle's air-fuel management system highlights the importance of accurate readings for optimal performance. Throughout the troubleshooting process, it is crucial to analyze data carefully and employ software updates and ECM inspections for effective resolution. The symptoms of this DTC often impact driving experience, emphasizing the need for timely interventions. Implementing preventive maintenance routines can mitigate recurrence and enhance the reliability of the vehicle. Overall, mastering the nuances of this DTC equips technicians with the skills necessary for successful diagnostics and repairs. Please like and subscribe to the channel. See you next time.